Algebra 3, Chapter 2, Section 5, Transformations of Functions. Okay, we have several types of transformations. There's 3 of them to be exact. We have shifts, we have reflections, and we have dilations. The first 2 are considered rigid transformations because the shape of the graph remains the same. It's just that the shape moves on the graph. Dilations will either compress or stretch the shape of the graph and are considered non-rigid. How to shift a graph. So we're going to start with the basic function f of x equals x squared and play with that a little bit. If we want to shift it to the left, we're going to add a number to the x, and it's going to look like this. Notice that the number is inside the parentheses with the x and the squares on the outside. Notice that it's kind of backwards of what you would think. You would think that if you wanted to move it to the left, you would subtract it because that's kind of the minus direction. But with x, everything seems to work a little bit backwards. So if we want to move it to the left, we actually need to add a number. If we want to move it to the right, well, then we're going to subtract a number, and it's going to look like that. Now, if we want to move it up, we add a number to f of x. Notice the difference here. We're not adding it directly to the x. The number is away from the x. The x gets squared first, and then the number gets added. And that's going to make it shift up. And to move it down, we're going to subtract a number from the x squared. Now, when we move it up and down, it works the way you think it should. So anything that happens vertically in the y direction is going to happen pretty much like you think it should. The x direction, things always seem to work kind of backwards. Now, reflecting. Again, we're going to look at the function f of x equals x squared. If we want to reflect it across the x-axis, then we're going to make f of x negative. So it's going to be f of x equals negative, and then in parentheses, x squared. This is going to reflect it across the x-axis, so it'll actually kind of flip it upside down. If we want to reflect it across the y-axis, we need to make the x itself negative. So it's going to look like this. Now, of course, with the function x squared, reflecting it across the y-axis doesn't really change anything because it's symmetric around the y-axis. But you get the idea of what you need to do to make that happen. Dilating. Now, this is where it gets a little weird because if you stretch a graph one way, it shrinks it another. It's kind of like pulling on silly putty. So, a stretch vertically will be accompanied by a shrink horizontally and vice versa. That being said, when you multiply f of x by a number greater than 1, it will stretch the graph vertically. Multiplying f of x by a number between 0 and 1, a fraction, will shrink or compress it vertically. So for example, let's use the graph of f of x equals x squared to write an equation for each function whose graph is shown. All right, what you're going to do here is you're going to look at basically where has the graph moved and write your equation. Pause the recording, give it a try, and resume the recording to check your answer. All right, this is a parabola that has been moved downward 1 space, so it's going to be x squared minus 1. Our second graph has been moved to the left, it has been moved up, and it has been reflected. So what that's going to look like is negative x plus 1 squared plus 1. Now you're going to identify the parent function and describe the sequence of transformations and sketch the graph. Here's a hint. When we're describing the sequence of transformations, the order they occur is going to follow order of operations. So you would name anything that happens in parentheses first and work your way outward from there. Pause the recording, give this a try, and resume the recording to check your answer. All right, the parent function here is x to the third. The plus 7 means it's a vertical shift of 7 units upward, and you see the graph there. Now we're going to identify the parent function and the transformation shown and write an equation. Pause the recording, give it a try, resume the recording to check your answer. The parent function is obviously x squared, and we have a reflection across the x-axis here, so it's going to be y equals negative x squared. Now we're going to identify the parent function and the transformation and write the equation. Pause the recording, give this a try, and resume the recording to check your answer. The parent function is the square root function. We have a reflection in the x-axis and a vertical shift of 1 unit up. So it's going to be negative square root of x plus 1. Now identify this parent function, describe the sequence of transformations, and sketch the graph. Pause the recording, give it a try, and resume the recording to check your answer. Our parent function is the square root function. The 3 in front of the x indicates a horizontal shrink by a factor of 1/3. Whenever the number that is being multiplied directly to the x, it indicates a horizontal dilation. And again, it works backwards. When it's out in front, if it was a 3 out in front of the square root, it would be a vertical stretch by a factor of 3. But because it's inside with the x, everything kind of works backwards. It's a horizontal shrink by a factor of 1/3. And you see the graph there. Okay, identify the parent function, describe the sequence of transformations, and sketch the graph. Pause the recording, give it a try, and resume the recording to check your answer. Our parent function is the absolute value function, and we are going to be moving it forward to the left. We're going to reflect it across the x-axis, and then we're going to shift it upwards 8. You see the graph there. Identify the parent function, describe the sequence of transformations, and sketch the graph. Pause the recording, give it a try, or resume the recording to check your answer. Okay, we've got the greatest integer function, it's a step function. It's going to be reflected across the x-axis, and then it's going to be moved upward 3. For this example, write an equation for the function described by the given characteristics. It's going to have the shape of x squared, but we're going to shift it 3 units to the right and 7 units down. Pause the recording, try to write the equation, and resume the recording to check your answer. Okay, our shift of 3 units to the right is going to be x minus 3, and then the square will be outside of that, and then minus 7 for the 7 units down. Now we're going to use the graph of f of x equals x squared to write an equation for each function whose graph is shown. Okay, what this does is it gives you a point that's on the graph. So this is going to allow us to find anything that might be multiplied. We already know something about the graph from what we're looking at here. Just to give you a hint, it's not been shifted, but it has been reflected. So we know it's going to have negative in front of the x squared. But it's also skinnier, so that means there's going to be something else there. So put a variable, like maybe negative a times x squared equals y, and then put the point in there to solve for that missing number. Pause the recording, give it a go, and resume the recording to check your answer. Okay, you should have g of x equals negative 3x squared. Again, what you want to do is you want to say that negative 3 equals negative a times 1 squared, and then solve for a. That's the number that's going to go out in front. The same idea, but question B. Now again, we can look at this graph and we know that it's skinnier, so we're going to need to find what number's been multiplied by it to make it that way, but it's been shifted 3 up. So we know we've got x squared plus 3. You're going to write y equals a times x squared plus 3, and you're going to put in 1 for x and 7 for y and solve for a. Pause the recording, give it a try, and resume the recording to check your answer. Okay, when you do that, you find that the missing number is 4. Everything's being multiplied by 4. So g of x is 4x squared plus 3. Now we're going to identify the parent function and the transformation and write an equation. And you're going to verify it using your calculator. Pause the recording, give it a try, and resume the recording to check your answer. Okay, this is x cubed, and there's been a vertical stretch. And you may wonder, how am I supposed to figure that out? Well, you can see clearly where the graph crosses certain points. It crosses the point 1, 2. Use that, just like we did in the last couple of things where they gave you a point, use that to find the missing multiplier.